So to start Unit 3, we're going to be actually looking at trig identities. And when we talk about identities are nothing more than a bunch of formulas. And we're going to get into proving trig identities throughout this particular section. So some of these formulas we actually saw back in Unit 1. So when we talk about our trig functions, they have numerous relationships that can be expressed as an identity. And again, an identity is nothing more than a formula. So an identity is an equation that is true for all values of the variables for which every term of the equation is defined. So for angles, we've been looking at trig notation as our variables can be in terms of theta. Remember, that's one variable that we can use for angles. We also can use sometimes an x that you see in algebra. We also have two others, which are called an alpha and a beta. Again, these are just variables that represent an angle. So just equivalent notations, when you see a trig function raised to a second power, this is actually equivalent to sine squared x, but not equal to the sine of x squared. So just remember, when you see a trig function squared, it's actually the quantity. When you are trying to prove or solve identities, the objective is simplify one side to mirror the other side. You do not treat this like an equation. You may not add, subtract, multiply, or divide to both sides of the equation. In other words, this is not an equation you're solving, so all the properties of equality are out the window. You may not cross multiply if both sides are fractions.